In this question, we are asked to calculate the forces in all elements of the following truss. And step number 1 is to calculate the reactions. First, for reactions, we need to assume a direction for these reactions. And we'll go ahead and assume a direction for RA. This is a roller, and roller will have only a vertical reaction, and it is up to us to assume direction for we'll assume it upwards. And for the hinge, we'll need two reactions, horizontal and vertical. So this will be the vertical reaction, and again I'm assuming it upwards, and it is okay if you assume it downwards, but the look of the truss and loading suggests that we do it upwards. And then the horizontal reaction, and if you look at the loads, you see we need something to oppose this value, so it will be in this direction. And it's up to you. If you assume it differently, that still be fine, but you will get a negative answer at the calculation, and you have to reverse it. So we'll name them. This is R A Y, and this is R B Y, and this is R B X. Now that we suggested names for these ones, let's again take a look at what are the unknowns. So this is one unknown, this is second unknown, and this is a third unknown. Now what we learned previously is from equilibrium equations, we have three equilibrium equations, and for three equilibrium equations we can resolve three unknowns, so this is valid for us to calculate these three unknowns. We have the sum of all forces in x direction equal to 0, and we have the sum of all forces in y direction equal to 0, and sum of all moments above a certain point equal to 0. So which one to use from these three equations? We learned that it is best practice to take the moment about a point where you have more than one unknown intersect or meet, like the following point B. See, if you look at point B, the unknown RBX and RBY will meet. It means that these two will not cause any rotation. So an equation of sum of all forces about B equal to 0 will get rid of these two unknowns. So that's why it is a good idea to start at this point. So we'll do the sum of all moments about point B is equal to 0. So before we do the numbers, we need to see what are the rotation direction for each force. For this RAY will cause a rotation clockwise, which is negative, and for 45 will cause a rotation counterclockwise, which is positive, and the 30 will cause clockwise rotation, which is negative. These are the three forces that will cause rotation about point B. So we'll go ahead and do the equation. So it will be, this is negative RAY, so we'll start with this one. So minus RAY multiplied by the distance from here to here, which is 20. 8 plus 4, 12 plus 8 is 20, multiplied by 20 meters. And then we do this force, which is 45, this is positive, so plus 45 kilonewton, and the distance is from here to here, which is 4 plus 4 plus 8 is equal to 16, multiplied by 16 meters. And then we have this force, which is 30 and rotates negative, so minus 30 kilonewton multiplied the distance is from here to here, which is equal to 4 meters is equal to 0. So I'll proceed with this by bringing the RAY to the right hand side. So I'll have 45 multiplied by 16 is equal to 720, and minus 30 multiplied by 4 is equal to 120, is equal to 20 RAY, and RAY is equal to 600 divided by 20 and is equal to 30 kilonewton. And because the answer is positive, so it means that the suggested force is upwards, so it is correct. That is the answer for this part. Now that we calculated this force, we'll update our sketch and remove this unknown. It is not unknown anymore, it is calculated, so the value for this one is equal to 30 kilonewton. You should always update your sketch as you go so that you'll see things clearly. Now we are done with the first equation of equilibrium. We would like to calculate this guy, and to do this we will apply the second equation of equilibrium, or whatever it is first, depends on the order you list them. So sum of all forces in y direction equal to 0, and this one we have this force is upwards, so it is plus RAY, and this force is downwards minus 45 kilonewton, and I have this force. I suggested this to be upwards, so record this as plus RBY, and there is no other vertical force in this truss, so is equal to 0. So now we substitute the values. This is plus 30 minus 45 plus RBY is equal to 0. If you isolate RBY is equal to 15 kilonewton, and again because the sign is positive, so it means the suggested direction for this force is correct, and that is like so. Now we will move to calculate. So this is, let's update this also again so things will be clear. And now say this is equal to 15 kilonewton. Now what is left for us is this guy. So we'll apply now the sum of all forces in x direction equal to 0 equation. And for this one we have this force, which is going east positive, so it is plus 30 kilonewton. And we have the reaction which we suggested to be going west, so it is negative, minus RBX, and there is no other horizontal force here, so it is equal to 0. So this means RBX is equal to 30 kilonewton, and again the result being positive, that means the suggested direction for the force is correct, and that is the direction for the force. That is for the calculation of reactions.